right, troops, so this is section 3, balancing equations. In a nutshell, obviously we just touched base on it before these AMI days, and I realized out of sight, out of mind is more important when you guys are working with me in the board, so you can ask questions and we work together and so on. So I'm just gonna kind of lay a little bit of the foundation work here. I'll go over a few of these slides to kind of help. And really it's drawn out where it's showing you one simple problem, and then I talk to you about in the email or in the notes that I left you about for today. I'll give you some sample ones I want you to dabble with, and then we plan on going over those on Tuesday when we get back to school after the vacation, okay? All right, so like I had said before, basically something I might have left out on Wednesday was a word called word equations. So like for example, if I had methane plus oxygen, when they react, I get carbon dioxide and water. Okay, yeah, we all understand that part. But sometimes, and especially with balancing equations, we have to write the chemical equation. All right, so in this particular case, I would help you, or you know it, but we know methane is CH4, and we know plus oxygen, which is O2. All right, then there gives us our reaction, the arrow, and it just said carbon dioxide, which is CO2, and water comes out. Okay, so then that is the equation. Then at the point when we know whatever we have on the left, on the right is what we mean by balancing it out. So it says in a chemical equation, such as the one above, the reactants, which are on the left side, as we know, this is where I know something's happening. All right, the arrow, the forms of products on the right side. Okay, so what we must make sure we do is when the number of atoms on the left equal numbers on the right, we use the term balanced. Okay, because remember, as we said, I think it was Grant won the coin toss on that when I said where does energy, and he said it just changes form and never goes away, which is true. This is the old law of conservation of mass. Review on the word law in science tells you something that's going to happen. It's not a thesis, it's not a hypothesis, it's not a question. It knows. It's been tested, and every time you apply this and you see the law, that means it's going to tell you the same thing is going to happen every time in line with that definition. So, in the law of conservation of mass, it basically states that energy never disappears, it just changes forms, okay? Right? It has to, and it's equal on both sides. So you cannot balance chemical equation by changing chemical formulas themselves, because that would change the substance, meaning you don't change the CH4 to an H4, you don't change H2O water to CO2. That's different, it's like changing the ingredients in baking a cake. You're gonna get a different taste, different substance, okay? So it's all about matching and balancing the left and the right side with the amount of molecules, okay? All right, so it's referred to as balancing equations. All right, so the balanced chemical equation, basically, the coefficients are the numbers in front. Remember, the lower subscripts, we don't change those. That's part of it. So in a sample here, I'll show you. Okay? All right. So we take our little example formula on 2 slides forward. When we see this, we have CH4 plus 2O2 is equal to CO2 plus 2H2O. So what this is telling you is you have one molecule of CH4, 2 O2s, look, there's 2 O2s because these are 2 units. And when they react, I had CO2, one molecule of CO2, and 2 water molecules, okay? So remember, the coefficient in front is telling you the whole unit. So that's having 2 waters, all right? So remember, the little guy below the actual letter is matched up with that. So I know that H2O has 2 hydrogens and 1 oxygen, but when I put 2 H2Os, I have 2 water molecules, just like I have 2 O2 molecules here. Okay? So this is where you add when we balance. It's always in front of the various compounds. You don't change these or add down here. Okay? You just balance. All right. So here's a little picture. So we have this big one. There's ethanol. Here's the written one. Okay? And you would not have to know this stuff as well. But there's the formula. Oh, and here's a little extra something, which is no big deal. See the little parentheses, lowercase l? That's telling you this comes in a liquid. All right. This tells you little g means this is a gas. The CO2 is a gas, this is a gas. So it's just those little symbols that you may not know what type of state of matter they're in, and that's what that means. Or it could have an S, it could have been for solid, okay? All right, so liquid, solid, gas type of stuff, okay? So here's our formula. We got ethanol plus oxygen gas, and when they react, it's left with carbon dioxide gas and water, okay? So you see that this equation is already balanced, and an easy way to do that is just add things up. So let's count. Let's just, even though we haven't worked on the problem yet, but right here. All right, so we know we have carbon, hydrogen, and oxygen present in this formula. So I'm going to write carbon, hydrogen, and oxygen. This is what we're going to get in the habit of doing here. Okay? And we already know this is balanced, but this is my reactants, and this is my product. So on this side, so let's count my carbons. There's 1, 2 carbons, right? Okay? And then we're going to count the hydrogens. There's 3, 4, 5, 6, and then over there, so there's 6 hydrogens. And now let's count the oxygens. 1 H, and 3 times 2, okay? Because there's 3 O2, so 3 times 2 is 6, plus this one single one, that makes 7, right? Okay? So let's add up the other side, they're over here. So let's add up our C's first. 2 times 1 is 2. 2 carbons. Oh look, that's balanced, just like we already knew. Then we go to 2 times 2, there's 4 oxygens. And 3 times 1 is 3 more oxygens. 4 plus 3 is 7. Oh look, that matched up, that's balanced. And let's do our hydrogens. No hydrogens there. 3 times 2 is 6. Oh look, as I already told you, but I was showing you this is how we do it. And that's how we check. 2, 2. I have 2, 6, 7, 2, 6, 7. I know that this already, though, as we told you, but just showing you what to look and how to count. And that's the whole point of this. The more we practice it, the easier it is. Okay? Knowing how to do it. Okay? So that shows you, oh, that thing's balanced. No big deal. All right? Okay? So chemical equations, it's just showing you various ones. There's a little S for solid, liquid, and aqueous. Don't worry about that. You don't have to pay attention to these. I won't ever put these, but in the samples they gave it. That's just telling you the state of it. Has nothing to do with balancing the equation. Just tells you what state it's in. Okay, meaning solid, liquid, gas. Okay. Okay. So let's go to the simple mass scale problem. That's what I want to get to. Okay. So we have magnesium plus oxygen creates magnesium oxide. So these are things you've already what's built up to it. The naming. All right. So you could write this equation for me even if I didn't give it to you. Right. Because you know, looking up your periodic table, magnesium, okay, which of course is Mg, and it's a 2 plus charge. And oxygen is a negative 2 charge, so we know that it's going to look like MgO, okay? So here's what it would look like. Magnesium, which we know, plus oxygen, which we already know oxygen pairs up as 2s. But if we were to do the old crisscross method, we'd have Mg2 plus and O2 minus. We're going to crisscross, they canceled, this is what it look like, okay? So we know magnesium plus oxygen gives us magnesium oxide. We also know that from our last little 10-minute video, which I know you've watched, okay? A plus B gives us AB. This is also a synthesis reaction, right? Because I'm adding 2 things together to form a compound. So this is not only an example of a synthesis, but this is also showing you the actual equation being created. So now all we have to do is balance it. So we would check, and it's going to show it, but I'm just going to do it like this. We have magnesium, and we have oxygen. I make my little grid. Here's my reactants on the left, my products on the right, and I'm just going to count. So I have 1 magnesium, 2 oxygens. I have 1 magnesium, 1 oxygen, okay? So, I got to balance it. So the key thing here is, all right, so if I have 2 oxygens already here, sometimes they may change, so we have to play this. So remember, I like to put lines here as well, that the places, if I add a number, that's where I put it, okay? I don't mess with the bottom. So, if I have 2 oxygens here, I need 2 on this side, so if I put a 2 here, now that changes 2 Mg, so this changes this to a 2, but 2 times 1, that balances the oxygens, okay? So then that's pretty easy because since Mg's by itself, I just put a 2 here. 2 times 1 is 2, okay? And you'll see in a second, and it's balanced. So all I had to do is add a 2 there and a 2 there, and it balanced the equation. You're going to see that here in a second on the other slides, okay? But the more we do it, the easier it is we see it. Okay, so we're going to balance this equation, all right? So, wow, that's exactly what I did. I wrote out 1, 1, 2, and 1, boom. So I just did this with my marker, and now you're seeing this on the slides, okay? A little quicker, all right? So then like we did, we added the 2 there, which made us our 2 oxygens, but then that threw this off, so then we added the 2 there, which you're going to see here in a second. and balance it out, which we just did, okay? And it's a simple one to do, okay? Some of them can be kind of difficult, but it's not about making them harder, but making you understand the importance of what you have on the left in the equation, you got to have on the right side of the equation. Energy doesn't go away, it just changes forms. So it's all about balancing, okay? All right. So there's what it was, that's the balanced out equation, and that's the way to check it. You'll make your little grids, like I said. You should always get in the habit of doing that little thing, like I said, where you do your reactants, your products, you list all the elements that you have, like in this case where we had magnesium, and then we had oxygen, and then we're doing this same thing right here, real simple, doesn't take much, we're just adding up and checking. 2 times 1 is 2, it's balanced, 2 times, I'm sorry, and then nothing here in front, so there's 2 oxygens. So then I go to this side, 2 times 1, 2 mgs, as we know is balanced. 2 times 1 is balanced. Bing, bam, boom, done. Okay? So I did it again, just like the slides did it, and I wrote it out twice right next to it. Okay? All right? Now the equation is balanced, has equal number on each side of the atoms, and we're all good. All's happy in the world of chemistry. Okay? So then this last little slide, I'm just going to introduce the word mole. Not mole as in the little blind thing that crawls around through the ground. But remember, the term mole refers to a unit of a measurement. So like we would say, if I had 1 mole of magnesium, that's magnesium by itself. If I had 2 in front of it, I had 2 moles of magnesium. If I had 14 in front of Mg, I know I have 14 units. So the term mole represents 1 unit of either an element or a compound, okay, together, right? So we'll get to that a little bit to make sure we understand that next week too as well. But the first things we're going to want to be able to do is make it easy, those 5 simple reactions, just practicing that, okay? The synthesis, decomposition, combustion, single and double displacement, and then baby stepping through balancing equation, understanding that, okay? All right, so we're not going to worry about the last couple slides on this with mole ratio, even though it's in there. We'll talk more about that. I didn't want to go too much into detail and get the video too long to where you want to go watch Netflix, okay? So now what I'm going to do is I'm going to put that little tiny sheet I held up and said this is what we were going to do, but we ran out of time. I think it's got 9 little simple equations on it. I'm going to upload that into Schoology, and I want you to try and attempt to balance some of them. All of them would be awesome. It wouldn't take long. Or at least try what we just watched in this 10-minute video, so then we can start doing them together on Tuesday. Okay, you guys can do that for me. You've had Thursday, Friday, Saturday, Sunday, Monday, 5 days. Okay, all right? So we can dabble with that, all right? Okay, so if you have any questions or something or whatever, email me, okay? Otherwise, I will see you Tuesday. Enjoy the rest of your week. I'm going to shut this off now.